Okay, first thing for today, we're talking about the decibel. Okay, it's really not important, for the program, but you have to know the basic, the thing that they will be using in part of in electronic. Okay, first thing, okay, let's see. The decibel unit is important in amplify measurement. The decibel is a measurement of the ratio. Remember, that's just a ratio of one power to the other or one voltage to another. Power gain is expressed in the decibel dB. In this formula, AP dB equal 10 times log of AP. Remember, AP, that means A means the gain, P means power. That means AP equal P out divided to P in. Okay? Voltage gain is expressed in decibel in this formula here. AVdB, 20 times log of AV. AV means có voltage gain and equal V out divided to V in. 0 dB reference. The maximum gain equal a mid-range gain and assign a 0 dB value. Critical frequency also known as cutoff frequency, corner frequency, or break frequency. That means three different names, same thing. At this frequency, output power drop to 1/2. Power drop to 1/2 of its mid-range. Okay? APdB equal minus 3 dB. Also, at a critical frequency, output voltage is 70.7% of its mid-range. Okay? AVdB equal 20 log of 0.707 minus 3 dB. dBm, power measurement, a unit that is often in measuring power is dBm. The term dBm means decibel, reference to 1 milliwatt. Okay? dBm means decibel reference to 1 milliwatt of power. When dBm is used, all power measurements are relative to a reference level of 1 milliwatt. Thirty dBm equal how many watt? Okay. You understand the decibel just a unit when they working on communication. That means RF radio frequency. Okay. So basically, you cannot be a RF technician. Okay. You are just a very basic electronic technician. However, that RF technician, they working in the lab when they measure. Okay. They're using dBm. Okay. So we're not using dBm. We're using watt, milliwatt, or kilowatt. However, RF, they're working on dBm. Okay? So you have to see the relation between dBm and watt or kilowatt or milliwatt. So now they say they get 30 dBm. They want to know equivalent to how many watt. The solution. Okay. dBm. The formula for the power will be, okay, 10 times log of power divided to milliwatt. Okay, and they will be equal 30. Now, then you can take the log of P over 1 milliwatt.
Medicare Department at Healthcare Benefits. How are you today?
So now log of P over 1 milliwatt equal 30 divided to 10. You get number 3. Okay, so now you enter the log P over 1 milliwatt. That's the power of 10 equal 10 power of 3 equal 1,000. That will be telling you P equal 1 milliwatt times 1,000. You get 1,000 milliwatt or 1 watt. Okay, that means if they given you the dBm, then you have to converting into the watt. This is the formula here. dBm equal 10 times log of power divided 1 milliwatt.
Hey, Mr. Pham, could you stay right there?
What?
Right, yeah, right there. It says APDB equal -3 dBm, and then it says AVDB. Yeah, right there. If you go the log, if you go log 10 log 0.707, do that give you minus 3 dBm? I'm asking.
3 dB, not dBm.
I mean dB. Does it? But does it give you? Because it's. I guess I couldn't get it. 10 log 0.707.
Okay, now, if you're talking about power, are you talking about voltage? Okay,
Power first. Power first.
power first. Okay, they say frequency output power drop to 1/2. Okay, that means minus 3 dB. They drop to 1/2, 0.5. How,
But I guess what happened is I put in the calculator 10 log 0.707.
that's what you're talking about voltage.
No, voltage is 20 log.
Yeah, 20 log, but if you using the power, you have to using 10.
Right.
10 log of 0.5.
Where'd you get the 0.5 from?
That's what they said right here. Power drop 1/2.
Oh, okay. All right.
Power, they drop
But
1/2.
okay, I guess, well, forget it, because they doing voltage. But thank you anyway, Mr. Pham. Thank you.
Okay. For the voltage, they will be dropped 70.7%. Okay. However, power drop 1/2. Okay. They say they want to add 1 dBm to 1 dBm. The problem is you cannot add dBm to dBm. Okay? What they want, first thing you have to change the dBm to the watt, milliwatt, or kilowatt. Then you can add. Okay? After you add watt or milliwatt, kilowatt, then now you're converting back to dBm. That is the key point. Okay? So they say merge them to watt or milliwatt, then add them. When done, convert it back to dBm. Okay? dBm equals 10 times log of P1 over 1 milliwatt. That is the formula. Equal 1 dBm. Therefore, okay, log of P1 over 1 milliwatt equal 1 divide 10. Okay? And then you can anti-log P1 1 milliwatt equal 10 power of minus 1. Is it right? 0.1 equal 1.26. Then P1 equal 1 milliwatt times 1.26. You get 1.26 milliwatt. Okay? Same thing, you can change 1 dBm, okay, into the milliwatt. You can get the same 1.26 milliwatt. Okay? Then you can add P you get P1 plus P2. 1.26 adding to 1.26, you get 2.52 milliwatt. Okay. And now dBm equal 10 times log of 2.52 milliwatt divided to 1 milliwatt given to you 4.01 dBm.
So we have to remember that dBm is when we're doing power, correct?
Now using, that power of voltage, that's okay, but they apply in communication.
But is dBm mostly for power, or is it for power and
Power.
voltage?
For power.
For power.
Yeah.
Okay, thank you.
And the formula, remember, okay? The formula will be, this is the formula using all the time. dBm equal 10 times log of power divide 1 milliwatt. Okay? So, cannot add dB watt to dB watt or dB volt to dB volt. Merge them to watt or volt, then add and convert it back to dB watt or dB volt. Okay? dB watt equal 10 times log of power divide 1 milliwatt. dB volt equal 20 times log of volt divide 1 volt. So that not on of the formula we need to using when we working on decibel. A data sheet say that output amplifier is 24 dBm. What is output power? So basically they get a dBm. How come they get dBm? The thing that they're working in the RF lab, the thing that they measure, they have to using dBm. Okay. However, we not deal with dBm again. We deal with the power, like watt, milliwatt, kilowatt. Okay. So you have to convert it. If you get dBm, converting to the watt, milliwatt, or kilowatt. Solution. You remember the formula. Okay. dBm equal 10 times log of P over 1 milliwatt. And that equal 24. Okay? Equal 24 dBm. And now you take the log only. So log will be equal P over 1 milliwatt equal 24 divided 10 equal 2.4. Okay? Now, remove the log, anti-log. You get P over 1 milliwatt equal 10 power 2.4. Okay? And that equal to 51.2. So now you can calculate P equal 1 milliwatt times 251.2. You get 251 milliwatt. Note, anti-log is the base 10 raised to the dB over 10 power. Okay. A data sheet says that output of an amplifier is 10 dBm. What is the output power? Okay. A or B, okay, or C or D. You calculate telling me which one is correct, A or B or C or D. They get 10 dBm, and now they want to know the output power. They will be in what milliwatt, kilowatt. So you know the formula, you have to use it. Okay. dBm equal ten times log of power divide 1 milliwatt. And that they say amplifier is 10 dBm equal 10 dBm. Okay. And now you want log only. Log P over 1 milliwatt equal 10 divide 10 equal what? Okay, anti-log, or remove the log, then you can get 1 milliwatt equal 10 to the power of 1. 10. So, let's see. Log of P over 1 milliwatt equal 1. So, that will be P. Okay, 1 milliwatt, okay, equal 10 to the power of 1. Okay, equal 10. That will be telling you P equal 1 milliwatt times 10. Okay, the answer will be A. The thing I did, lecture will be very short, okay? Not much. Very basic thing we have to know how to do. Cascaded amplifier. That's telling you, you get the first amplifier, gain AV1. Second amplifier, gain AV2. Input V in, output V out. Okay? So, if you want to calculate the total gain, okay, then AV total gain equal AV1 times AV2. Okay? However, if the gain in dB, then you cannot multiply. You have to add them up in here. Okay? AV in decibel equal AV1 in dB, adding AV2 dB. So you see the difference. Normally the gain, total gain equal AV1 times AV2 times AV3. Keep going. However, if the gain they're using a decibel, you cannot multiply. You have to add them up. Impedance matching. All resistance should the same. RG equal R in R out R L R. Okay, that means all of the resistor input, output, they want it to be the same. Okay, matching resistance. Impedance R in microwave system 50 ohm. Impedance R in TV 75 ohm coax cable or 300 ohm twin lead. Impedance R in telephone system is 600 ohm. You understand it that signal transmission resistance impedance have to be the same. Otherwise, you will be lost. At hyper frequency in microwave, dB is the usually unit used where the reference at 0 dB watt is 1 watt. dB volt is reference to 1 volt. Okay, dB watt, this is the formula. dB watt equal 10 times log of P over 1 watt, and dB volt equal 20 times log of voltage over 1 volt. Example. For example, okay, for amplifier, so here, you get input is 2 watt, output 200 watt, okay, power gain in dB equal 10 times log of output 200 watt divided to input 2 watt, that given you 20 dB. Output power dBm equal 10 times log of 200 watt divided 1 milliwatt. You get 53 dBm. Okay. Output power. Okay. 10 times log dB watt equal 10 times log 200 watt divided 1 watt. You get 23 dB watt. That's what they're using, this formula. Okay. In the input power, power in equal V square over R. Output power P out V square over R. You understand? In the electronics, you already calculate the power. We get 3 formulas to calculate the power. I don't know if you guys remember or not. P RI square. One formula. P equal V square over R. Next, V will be equal V times R. So basically you get 3 formulas, okay, to calculate the power. Okay, so basically that is just a review. Okay. Some we will already given you the solution. So you have to go through that. Okay. Now we'll see. Amplifier at the input 3 millivolt. and output 5 volts. What is the gain in decibel? That means you get the
It's 5 divided by 3 millivolts.
V in 3 millivolt, V out 5. So gain will be equal V out divided V in. However, make sure they have to be the same unit. Okay, 5 volt. And the gain, they say 3 millivolt, you have to convert it into the volt, 0.003 volt. So that's what you get, 1666.7. Okay, and now AV in dB. You know the formula, right? 20 log of V out over VE. Okay, 20 log of 1666.7. Okay, that means right here, given to you 64.4 decibel. Okay, and the next one, filter head, power input 50 milliwatt, output 2 milliwatt. What is the gain? Or attenuation in decibel. Okay, you understand attenuation? That means loss. Okay, solution. V in 50 milliwatt, P out 2 milliwatt. Okay, AP mean what? That means the gain of the power equal P out divide P in. 2 milliwatt divide 50 milliwatt, you get 0.404. Okay, now you want AP. AP in dB equal 10 times log of P out over P in. Okay, 10 times log of 0.04. Okay, and that come up with minus 13.98 dB. And number 3, a power amplifier at 40 dB gain. At output power 100 watt. What is the input power? Okay, now see what the solution they try to do. AP, that means power gain equal P out divide P in. Okay, and that equal 40 dB. If P out 100 watt, what is P in? Okay, so basically APDB equal 10 times log of P out over P in equal 40. Anti-log, you take 40 divide 10, you get 4. Okay, P out over P in equal 10 to power of 4. You get 10,000. Okay, P in equal P out over 10,000. Okay, equal 100 watt. Divide 10,000. You get 10 milliwatt. Okay, on this calculation, if you get the time, you can try to do it. Okay, to see you can get it or not. Okay, if you get any question later on when you're working on, and let me know. We help you out. Okay. Like in here, they add following 0 dB volt to 0 dB volt. You cannot add dB to dB. You have to convert into the volt. You add it, then convert it back to dB. Same thing. Add 20 dB watt, okay, to dB watt, same thing. You cannot add dB watt. You have to convert dB watt to watt. Then adding the watt, convert it back to dB watt. You know the formula here. Right here. dB watt equal 10 times log P over 1 milliwatt, or dB volt equal 20 times log of volt over 1 volt. Okay, so that it cover everything for the dBm. Okay, some formula you have to memorize. You have to know basic, or when you see, you recognize. Okay, any question about a decibel? Okay, if it's not, then now we go back to the electronic. Last time we already talking about bipolar amplifier, okay? And we already talking about common emitter, okay? Common collector, and then the last one will be a amplifier of the common base. Okay, that last time we already did it. Only thing what I want you to make sure, okay, for the amplifier, you get bipolar transistor. You get CE, common emitter, CC, common collector, and CB, common base, only three. Okay, and basically what you need to do, okay, try to see what with the formula will be helping you to do calculation, okay? Like, that one here, what is the output RC, okay? Or what is the gain, V out over V in? When you do an example, that will be helping you, okay? To understand. And when you're looking the amplifier circuit here, basically you have to recognize what is the name of that amplifier. Okay? So this is a common emitter. Input applied to the base, output from collector. And input output will be our phase. Input positive, output negative. Input negative, output positive. That is a very basic. You must know. Okay? And also, name on C1 or C2. Okay? That will be a DC blocking or AC coupling. What that means? They not allow any DC go to the amplifier. only the AC signal can go. And C3 here, okay, same thing. At the point collector, you get 2 voltage, DC voltage, and the signal. Okay. However, when go to the load here, that means your speaker. They don't want the DC here to go to speaker. That's why they have to get capacitor, block that DC, only AC coming out. And the last one, C3. C3 is the bypass capacitor. What did they bypass? They bypass the AC signal, go to C2 to the route. That means they not go to RE. So RE, they bypass RE. So if you measure at this meter here, you can get a DC voltage. However, not AC. AC already go to the route. Okay? And with the bypass capacitor, they make the amplifier, the gain will be higher. Okay? And this is one very important for every technician. Basically, they're using the voltage divider, DC, to make the transistor working. On all the calculation here, you guys have to go through it. Okay? And this is for the AC. Okay? For the amplifier. Okay? Now, CC amplifier. Normally, you understand when I say CE amplify. CE. That means common emitter. That means emitter will be connected to the route in the amplifier. Common collector amplify collector will be connected to the route. That is common. Okay, for amplifier. And they get another name, emitter follower. Either name. Okay, only one. Common collector, emitter follower. The collector is AC route. You see that? Common collector at AC route. Common emitter at AC route. Common base at AC route. This will be stable voltage gain and high input impedance and low distortion. Okay? So, this is common collector is not a high gain. However, only thing they can get high input impedance. And this is the circuitry for common collector. Input applied to the base. Output will be from emitter. Okay? Input applied to the base. Output from emitter. C1, C2, DC blocking, AC coupling. Input, output will be in phase. Input go up, output go up, input going down, output going down. Okay, so very simple. This is the AC calculation. Okay, when we get exercise, then we'll go through that with you. Okay. On up example 2 here. They calculate everything, okay, for the whole circuitry. However, for the technician, okay, basically you don't have to go into too many details to calculate it, okay? However, you have to recognize, okay, what the name of the amplifier, what the purpose of capacitor in here, okay, and very basic calculation. This just the example. Last one, common base. Base ESAC route. Common. Input drive the admitter and the output from collector. No current gain, but at a high voltage gain. Low input impedance, high output impedance, high frequency application. That's what you try to memorize. Okay? This is summarize what you need to know. Okay? So this is a common base. Okay. Input apply to admitter. This one try to recognize the thing when you're working on bipolar transistor left volt, you have to working on this circuit. Okay? Input apply to admitter. Output from collector. Input, output will be in phase. Input up, output go up. Input going down, output going down in phase. Okay? And they already given to you. You want to calculate the gain of the amplifier. Will be equal RC. Okay? RC right here. Divide R prime E parallel with RE. Okay? You know R prime E. R prime E, that means what? Resistor from the base to the admitter. Okay? For the DC, from the base to the admitter, just a diode. However, for amplifier, they no longer be diode, they will be resistor. And that resistor we call R prime E. R prime E equal 25 millivolt. Divide IE. That is the formula for manufacture for bipolar transistor. Output, okay? Output resistance R out, okay? Equal RC parallel with RL. RC here. Parallel RL. Okay? Input resistance R in. R prime E parallel with RE. Output resistance RC parallel RL. C1, C2, DC blocking. Okay? And this is the example to doing calculation. Okay? If you get the time, you can go through that, okay, to do the calculation, okay? And this is a summary of all of the amplifier. CE amplifier, CC amplifier, and CB amplifier. Okay? And again, Darlington connection. Okay? Darlington transistor are manufactured with a transistor in 1K. Okay? You understand it when you connect the first transistor to a second one. Basically, you want to increase the gain. Okay? Beta equal beta 1 times beta 2. That means they go very big current at it. However, when you're working on this kind of circuitry, have to be very careful. Okay? If you shorted the round, okay, output to the round here, they cook right away. They will be burned. Okay? Okay, so that will be for the transistor amplifier. Okay, today we will be talking about differential amplifier. Okay, the next will be differential amplifier. Okay, now we'll see. A differential amplifier is a bipolar junction transistor amplifier that produce output that are function of difference between two input voltage. Okay? When the amplifier together two input, two output, that's what they call a differential. Okay? Differential amplifier. So this is the built-in differential amplifier. You get the Q1 and Q2. Okay? They make a connection this way. So this is the inside this symbol here. This is the differential amplifier. They get input 1, input 2, and they get output 1, output 2. Okay? That is the name, differential amplifier. Okay. Assume both Q1, Q2 identical. Both R2, R1, R2 identical. Okay? That means they have to be the same. Assume both transistors are identically RC1 equal RC2. Okay? You can get IE1 to Q1, IE2 to Q2. Both will be identical. Okay? IE1 equal IE2 equal IRE divided by 2. You know this going here, go down. This going here, going down. So that's why IE1 or equal IE2, and that will be equal IRE divided by 2. Okay? And IRE equal VE. Okay, either E minus VEE, VE minus VEE divide RE. Okay? VC1 equal VC2
Where's VE?
equal VCC minus IC1 times RC1. That means if you want to calculate the IRE, okay, then you take the VE minus VEE, okay, divide to RE. And VC1, that means voltage across RC1. Same thing RC2, okay, will be equal VCC minus IC1 times RC1. That one we already know to calculate the voltage drop. Okay, VE here equal VB. VB minus 0.7. You know that is 0.7 here. Okay. Okay, now the fourth thing, they exercise both input rounded. That means they round Q1, they round Q2. They connect the meter at output 1, output 2. That will be telling you both will be equal. Okay? That's an example. Experience. They do it and let you know. When the both inputs rounded, then the voltage at RC1, okay, Q1, and output Q2, they will be the same. Okay, now we'll see what they try to do on next one. They routed Q2 right here. Okay, they apply the input to Q1 and they connect the meter to output 1. That's what you get voltage. And output 2, that's what you get VC2. Okay? See what they say. For this configuration, sideway connect to VB1. Q1 is a CE amplifier. Is it C1? That means the Q1 is a CE amplifier. You know, CE amplifier input applied to the base, output from collector. Okay, So that's why Q1 is CE amplified. Input output Q1 will be inverted. So the input of Q1 and the output of Q1, they will be opposite. Therefore, CE amplifier. VB2 is rounded here. Q2 ACB amplified. How come? How come they say CB Q2 is CB amplifier? What's CB amplifier? Remember, CB amplifier input applied to admitter and output from collector. So basically, you can see when they apply sideways here, okay, then you output here, you get amplified, inverted, and at middle here, you still get same sideways. So this sideways will be applied to Q2 at middle. And that is a collector. So that's why Q2 will be CB amplified. One will be CC, CE, and another one will be CB. Okay? CB amplified. The output will be in phase with the input. Okay? Q2. Okay? Q2 CB. Input and output Q2 in phase. That's what we already learned. Okay? When you're looking into that circuitry, okay, first thing you have to understand, they rounded the bay of Q2. They apply sideways to the bay of Q1. And the Q1 will be common admitter. Common admitter. So that's why at the admitter you get a sideways. However, this sideways will be opposite to the input. Okay? And also, you can get a sideways here, go from admitter Q1, go to admitter Q2. Okay? So Q2 input go to the admitter, output from collector. So they will be a CB amplifier. And a CB amplifier, input, output will be in phase. That's what when you're looking into this circuitry, you're able to recognize. Okay, try to see. Now they do a different, just opposite to the other one. They're telling you, now they round. Okay, they round Q1. They apply to Q2. Okay, so now Q2 will be CE amplifier. And a Q1 will be CB amplifier. Okay? They already explained to you here. They just do the opposite to the other. Okay, now you see. So they just repeat it. This is a sideway. Apply Q1. Q2 rounded at the base. Okay? So input here. Apply to the base. Q1. Output here. From the collector Q1. Common at meter. So input output 180 degrees out phase. Okay? And when you apply the sine wave, then the sine wave will be go this way. Go to the S meter of Q2. Okay? Input applied to S meter. Output from collector. So Q2 will be common base. Input, output will be in phase. So let's make more clear for everyone. Did you get any question or anything? Okay, remember, we're just talking to you a very, very basic to be a technician. The thing is, in the class I saw, your guy around 20 students. However, in a meeting for lecture, it's not much. I don't know the other student, what they doing. How come they can get through the Tech 1? The level just a part of the program you have to do. However, you still get the assignment. And you still get the quiz. You have to spend the time to do it. Okay? You have to combine everything in order to say, okay, you are satisfied to be Tech 1 technician. Okay? Otherwise, I don't know what to do. Any question, any idea, anything we can have. The thing is today, okay, I will be stopped at this point. The thing is I don't want to keep going. We don't have more students. So I don't know what can they do. If we keep going, then a lot of students will get lost. Any idea, anything else, just bring it up to me. The thing is after this differential amplifier, then we can go up to like inverting amplifier, okay, non-inverting amplifier, summing amplifier, and something else. Try to finish that. And you go to the JFET fusion emitter, JFET, transistor. Same thing, like bipolar transistor. We get a minor difference between JFET and bipolar. Then you can go into the filter, active filter. Then we almost close to the end of the lecture. Not much. Okay, any question, anything? So, Mr. Smith, you see this time it's better for you?
That's not too bad, Mr. Bam, not too bad.
You've been with me for a while.
Hey, Mr. Bam,
Yeah.
so
Well,
on that first one, the input is 180 out from the output, huh?
input.
Yeah, V out.
Uh-huh. Then what?
Oh, okay. Well, because I was looking at it says V out 1, and then it's got number 2, the one on top.
VL2.
Yeah,
Okay. The key point. A. When you're looking into the Q1, input apply here, right?
right,
Output here.
right.
What amplify? They will be
Common emitter.
common emitter. So that's why they're telling you input, output, out phase. You see that?
Mm-hmm.
In positive, negative out, and so on. And then you're looking on Q2, input apply emitter, output from collector. So they will be CB amplifier. And a CB amplifier, input, output will be in phase. See that?
Mm-hmm.
That's the only thing we need to know before we can move further. First thing they already telling you, they connect Q1 input, Q2 input to the ground. Okay, see what output look like. And now they connect input to Q1 and the input Q2 routed. So you can see Q1 is CE amplified, Q2 will be CB. Next step, they connect input go to Q2 and Q1 input will be routed. So one will be CE and another one will be CB. Okay? And the last, they connect input to Q1 and input to Q2. That's what will be in the next. So that's why you have to try to make sure for bipolar transistor amplifier, you need to recognize Is it CE, RCC, RCB? What input output for CE amplifier, CB, or CC? Okay, that's what you have to know. We don't have to go to too many details, but that's a very, very basic for understanding before we keep moving.
And Mr. Pham, and then just one last thing. So for the common emitter, that's where the input and output, you got the phase shift. The common base, it stays the same. And what about the common collector? Is it the same or it changes?
Same.
The same. So that
Yes.
the common base and common collector has the phase, it stays, but input output stays the same, and the common emitter is the only one that changes.
Exactly.
Okay, got it.
Only common emitter, they inverted. And the other one, common collector, common base, will be input, output will be same phase. Okay?
Got it.
Okay, so any question, anything?
Thanks a lot, Mr. Pham. Have a good night.
You too. Okay? Will be. Hope you guys get a good weekend, okay?
Thank you.
Weekend. Thank you.
Bye-bye.